What up, everybody? Welcome to Coffee Hour. We made it to the end of the week. It's Friday. Thanks for spending your day with me here on Friday. Again, getting ready to wind down. Hopefully, you're going out to your job site or whatever you're doing today. You're going to be safe. Got to make it through the day so you can get to the weekend and get refreshed so you can do it all over again next week. That's what we do. So, thanks for joining me, folks. If you're new to Coffee Hour is a show we do every day, Monday through Friday. And we talk about the National Electrical Code, all things electrical, different topics, different areas that we discuss. And then we also replay those at 5 o'clock each day for those that missed the morning show and want to watch it. More than happy to watch it there. Of course, it's also recorded and on other platforms as well. So be sure you check it out. If you miss the morning drive, got a guy called me yesterday afternoon and he thanked me for the fact that he was watching it there and he called me and asked me a question. So appreciate all of you that join us and follow us and share it on all of your own social medias and things like that. Okay. So anyway, thanks for joining me. As always, I like to give shout outs to folks that join us here in the morning and give a little bit of who you are, where you're from, and all those type of things. And so today we're going to be finishing up. Our series on cable trays. And again, if you have topics, please submit them to paulabernathy.com. It's very hard for me to just go into a random lesson on things that people throw out when you don't have things to show and present. Okay, it's not the way the show works. So I'll answer questions, but if you want a topic for a lesson or something like that, then you got to go to paulabernathy.com and you got to submit it, and we'll do something there. That type of scenario. Okay, so make sure you do that. Again, paulabernathy.com is where you would submit topics and show ideas and stuff like that. That's the place to go for that. Okay. All right. Well, again, as I said, we're going to be trying to finish up the cable trays. We're going to be finishing with channel cable trays, which is just a smaller type of cable tray. In many cases, a U shape. It's small. It can be solid bottom. Can be perforated. But at the end of the day, it's usually limited to the number of cables that go in there. And to be honest with you, most of the ventilated and solid type of channel cable trays are really used for communication, not so much power because of their limited size, that type of thing. Okay, so the majority of the cable trays that we'll deal with are going to be the ladder or rung style ventilated trough, those type of things. Some solid bottom applications, but again, because of heat dissipation and all, most people try to steer away from the solid bottom, unless of course you're installing a listed cable tray in an environment that may be a hazardous location, and then there's certain parameters about the construction of some type of tray that may go in that type of environment. Okay. Again, not what we're talking about today. We're just talking general, and we're ending up this thing on cable tray, and we'll talk ampacities today and be very general with the ampacities, because I'm sure when we talk about ampacities, it generates other questions. But the goal is going to be to not make the cable tray and ampacities complicated, because it can be complicated where it can cause us to look at 310.14b, which is engineering design, and an engineer might be able to use something called a Near-McGrath, and they can do a calculation that would generate a conductor value that a conductor can handle more current than it would using the tables in the NEC. I usually tell you, I'll leave that to the engineers. For me, anytime that I consult for people or I talk about ampacities and conductors, I always refer to 310.16 or 310.17 where applicable. And that's where I work from. And that's what I recommend before we get started in this, that you work from. There are going to see some examples today in ampacity where if the conditions are right, if you're doing like a triad or something like that in a single layer inside of a cable tray, that you have the proper spacing, then you can use ampacities that might be equate to like what's for a messenger. So it basically acts like a free air or a messenger, and the ampacities are a little higher. So that might get you out of some stuff. But again, it's all about the design. And typically this is going to be engineered out. So again, when we get to ampacities, we're going to try to keep it as simple as we can. And I want to mainly hit some of the areas where people get confused on it. Okay. Especially since it's only an hour and it's not a full in-depth lesson on going too deep. So again, nothing's to take the place from getting a code book and reading it and studying it. And if you know it better than me, that's great. Okay. So, all right. So let's do some shout outs real quick to folks that have joined us this morning. And thank you for joining us. Marlon, thank you for being here. David, down in Florida, thank you for being here, David. Tino H. Tino, thank you. Thanks for being here this morning. Charlie's in the house, got the little one with him. There you go. Get them learning early. That's what I'm talking about. Cray Cray's in the house in Nashville. It most certainly is Friday, my friend. So thanks for being here. Let me skip mine because mine don't matter. Again, what's up, Cray Cray? Hola. Paul is in the house from down in Houston, Texas area. Paul, thanks for joining us. By the way, if you do need any, I recommend out there for your company, if you need any type of printed stuff done, any marketing stuff done, things like that, get with Paul. He does that kind of thing. He does printing. So if you need some stuff done, banners, probably anything for your business, shout out to Paul. Paul, if you want to give put a comment in there, your email or your link or your website or whatnot that people can go to, have people go that way. Again, to promotional material. If you're giving away stuff for your company, you're doing local shows, maybe the home and garden shows and stuff like that, and you need some promotional stuff, share the love, reach out to Paul. He'll be able to help you out with that. Jonathan, it is Beatbox Friday, although I might not do the beatbox today. I'm just saying, Jonathan. Born to Plum. I did get your question, Born to Plum. I will cover it on a podcast, but I will tell you that typically those boxes that are part of a listed product, we don't there's no stamping on them. That typically what we refer to is that you go to the manufacturer's instructions, and the manufacturer's instructions are a part of what it was evaluated for. So when we think of boxes in Boxville, when it's metal boxes, we're pretty much bound to 314.16 for those standard type boxes. And then non-metallic boxes will post on there the cubic inch values and things like that. But when it comes to the luminaires that are already pre-done, like the recess cans with the boxes, at the drivers and things like that, typically, just because it has 4 openings doesn't mean you cram it, but you would go look at the manufacturer's instructions, and the manufacturer's instructions should have in there the maximum number of this and that. And that's why it's so important for inspectors, because inspector could ask to see that paperwork for any luminaire, any ceiling fan. I mean, I know all of you probably throw those away, right? Just trash them. But they could, even GFCI instructions, AFCI instructions, they could ask for that at any time, and that's their prerogative. And again, every inspector is different. So they, their area, they may be having problems with certain things. And so they're more hypersensitive about certain things. So they may ask for that paperwork. So I always used to just take everything and throw it in the drawer in the kitchen. In the rough end, I throw it in a box. For every job, I'd have a Tupperware, or a job box, a plastic box. And anything that had an instruction manual, I would throw it in it. I just would throw it in it. We keep that on the truck for that job and throw it in it. And then when I'm doing the final, I take that same box, that little plastic box written on the top, homeowner's information. And I would just keep telling my guys, throw any instructions, any manuals you get, anything in that box, just throw it in the box. And at the end, when it was the final, I would take all of those instructions and put them in the cabinet or in the drawer. So I always just kept that. That was part of my management. That was part of what my guys would do. I never threw anything away when it comes to manuals. Now, if I have 5 ceiling fans and they're all exactly the same, I just keep one of the instructions and throw one in there. I mean, it's not like I keep them for all. Same thing with GFCIs. If it's one GFCI, I keep one little pamphlet and put it in there. Not for every one of them, but that's just my practice. That's what I used to do. Not because of inspectors asking for it, because I wanted to always make sure that the homeowners had their instructions for everything, right? And I didn't want them to come back on me. Was just me. I'm always been that super anal about that. So that's just me. Okay. So hopefully, Born to Plum, Jim, hopefully I answered that question. It really is. Go look at the instructions on the luminaires that you're using, and it should give you some detail for that. But hardly ever seen anybody question it. Mostly with those, you're going to loop in and loop out. So it's usually not going to be, you're not going to be using it as a junction point anyway, that type of scenario. So it shouldn't really become an issue for anybody. What's up, Peter? Glad to have you here. What is up, Adam? Glad to have you here, Adam. Appreciate you. Let's see here. What is policy? Made another beatbox rapping. There you go. No, I might, maybe it might, maybe I don't know. I'll see how I feel. Let's see. Alejandro says, could you talk about parallel feeders? Can you be more specific, Alejandro, when you're talking about parallel feeders? When you're installing feeders in parallel, you have to follow all of the rules for paralleling in 310.10h, or I don't know if it's, let me see here real quick. I don't know, is it H now with the code cycles? They change, and I have to check it just to see. 310.10. Let's see here. Is it H in the 2023? Is it G? It's G. So it's now G in the 310.10G, and basically it talks about your characteristics. So paralleling, if you're going to parallel feeders, they have to be at least 1 aught and larger, okay, for paralleling. You have to follow all of the rules, the characteristics, okay? So each set, so all the A's, if you had A, B, and C, and so you had multiple sets, then you have 2 A's, let's say 2 sets, 2 A's, 2 B's, 2 C's. All the A's have to be the same conductive material, all the same length, all the same characteristics, same for the B's and same for the C's. Now, could I have the A's be copper and the B's be aluminum and the C's be copper-clad aluminum? Absolutely, as long as the ampacities correspond. Okay, there's going to be a difference in sizes, obviously, but I have to keep the same characteristics per set. Okay, so per phase set. But other than that, I encourage you to go look at 310.10G for that situation. Now, why do we parallel? We parallel because we're trying to get more ampacity. We're not paralleling equipment grounds because of that, okay? The code just says what we do. They connect them all together in a parallel nature. But when we parallel ungrounded conductors and grounded conductors, and we say grounded, we're also talking neutrals in most cases. Not all cases, but most cases. We're paralleling in order to get more capacity. So basically, the easiest way that I explain paralleling and what we're trying to do is the same way in a stranded conductor. You have a stranded conductor, let's say a 500 kc mil, right? You have these like 37 strands or whatnot in there. Well, they're all acting as one, even though they're separate individual strands. But when you connect them together at both ends in a single conductor, it acts as one conductor and you're getting a certain amount of ampacity out. But each individual strand is distributing the current equally, right? And it's basically, so when you think of that same concept and you have multiple sets, it's the same thing, right? You're connecting them at both ends so that those multiple conductors per set or per phase, A, let's say, are acting as one conductor. Okay? Even though there might be multiple conductors for phase A, they're acting as one conductor. And you're going to get more current out of that because you have more conductor size, more circular mill, right? Does that make sense? So that's kind of the quick and dirty when it comes to paralleling, right? Just make sure you go check 310.10G in the 2023 edition, and it might be H in whatever edition you're in. Okay, just depends on. Does that make sense? Hopefully that makes sense. And that's the best I can give you, the quick and skinny on paralleling, that type of thing. Let's see here. Good morning, Erie. Fast Track student, glad to have you in the program. Remember, folks, if you're in our Fast Tracks program, use the Fast Tracks Interact to ask questions. It's built into your course. Lower right-hand side, you'll see the little blue, looks like a little cloud. Make sure you use it. We'll get it there. Answer your questions inside the program. You can also cut and paste there if you want, something you want to cut and paste from your lesson and say, Paul, can you explain this better? Then you can cut and paste it. Also, don't be afraid to try out the Trade Hog. You get something you don't understand in your course or in your program, and in the NEC in general, take it, go to Trade Hog. You get to at least try it 3 times per hour if you're not a member, and cut it and paste it in there. And again, if it's a long discussion, it's going to time out on you because it is limited. That's not us. That's chat. That is the way that the AI model works. And you just have to clear the chat and start a new one. But don't be afraid to ask the hog some things and see how it talks about it. Okay. What's up, Frank? Glad to have you here. A lot of hashtag wins going on. Hola. What's up, Red Dog? Only thing I know is Pablo and hola and all that kind of stuff, but I'm glad to have you here. You can teach me Spanish. We'll have Spanish session on here. Let's see here. Good morning, Christopher. Glad to have you here. What's up? My nephew from another mother. There you go. Let's see here, Frank. Glad to have you in the house. God, I don't know. Okay, that was my Fat Boys impression there for you. Let's see, Joseph. Welcome from. Is it sunny in New Jersey today? That's awesome. It's nice out here today too. I wish I had my mini excavator. I wish I had it because I'd love to get out and start playing around. I got a lot of projects and I'm going to record them because if I blow that thing up, I want y'all to see me blow that sucker up. That'll be funny. Expensive, but funny. Not so expensive. It is a Chinese version, okay, for all the haters out there that say, what? You bought a Chinese and you didn't buy a Bobcat for $40,000? No, okay. I'm electrical guru, but I'm a frugal guru. I bought the one for 10 grand. I'm just saying. Haters be haters. What's up, Terrence from up in D.C., Maryland, and Virginia? Glad to have you here. Gregory's in the house. Good morning. Glad to have you here, Gregory. Let's see here. Tino, I don't know if I can read this before it goes away. I work industrial a lot in the cable and trade. Not sure if it is because there is no inspectors, but the cables and more are more than one. Hold on, let me read that again. That's very long for my 10 seconds it comes up here. It says, I work industrial. There are a lot of cables in the tray. Not sure if it's because there are no inspectors, but the cables are more than one conductor. What's your thought? So as we've talked about it, and you got to go back and watch part 1 and part 2 this week when we talked about how to put the conductors or cables in a tray. So make sure you go watch that again, Tino. And there are applications where you're going to have more than one in there. There are applications where that you are required to put certain types of conductors or cable on a single row. And there are certain applications where you're able to stack it. It just depends. And again, when you start stacking, you got to worry about other things, right? So they're all different types of rules. Now, the stacking and putting more than one layer in it and all that kind of stuff, that's where we're talking about depending on the size of the conductor. And like we said, when you're mixing sizes, it can have an effect on being able how many you can get in there. But the ampacity is more impacted depending on the number of current carrying conductors inside of the cable itself. And we're going to talk about that today. But as far as the sheer numbers, the code gives us allowances. And when it gets to the one where it talks about the cross-sectional area, which is, I was talking yesterday to somebody called me up and I was answering a question for them about the area. It's the area of the cable, not the conductors inside of the cable. It's the overall. That's why I gave you the formula for calculating the area. So basically, you treat the cable like a conductor, and you have to know, you can get the diameter. Once you know the diameter, you can calculate out and find the area. And that's what it talks about when it says cross-sectional area, okay? Because a cable's got more than one conductor in there. And it is more complicated to try to do, each conductor because you still have the interstices, the volume between the conductors. You still have the sheathing. So we're trying to find the area. Okay, that type of thing. And so yesterday, go watch part 2, and I show you that example, and I even linked it in the chat for how to calculate the area of a cable assembly, that type of thing. But if you have no inspections at Tino in your area, then it's hard to freaking tell what is being done in those trays. And you're probably going to be, after you watch all these series, go back and watch it again, you're probably the only one in your area that actually knows squat about cable trays because you watch these videos and now you're starting to question yourself. You're like, holy crap, how do we do that? What's up? Gregory's in Conway, South Carolina. Love me some South Carolina. David Bueno. David's joining us from NYC. He's in the house. There you go. You are most welcome, Paul. Again, for all of you out there, if you need some printing stuff done, of all of our members here, we actually have a guy that does printing. That should be a benefit for you guys that need printing stuff done. Share the love. Reach out to Paul and get some printing done. let's see here. I told Paul, I'm very limited here. The promotional stuff we give away really is not in bulk. So it's not conducive for us to do that type of thing. But if I was going to do printing for shows, which we don't really do shows or something like that, I'd reach out to Paul and have him do it. I'd rather have Paul do it than just go to some random person because I know he's in the trade and I'd much rather share. It's kind of why I endorse these type of stuff like the wire waffle. The guy reached out and he says, I can't, what are you going to cost? What is the cost for you, Paul, to endorse this and do a video? And I believe it or not, and most people that know me, I told the guy, I said, Hunter, I'll do it for free. I'll promote this for free. I'll tell people about it for free. I don't want no money. I don't want you get a picture of me endorsing it and you put it on the product. I wouldn't charge you for that. There's a lot of people that will. If you're on TikToks and all those people take money. They'll take your money in a heartbeat. I don't want your money. I promote something like this because I think it's a great idea. I wish I had thought of it. Okay. So, I invent stuff all the time, cables, different types of cables, but I didn't think about something like this. At the end of the day, this solves a violation that's very common, 312.5C, where you're required to connect to secure every cable to a cabinet, right, or enclosure. Well, if you bring them all through one big knockout, that's not meeting the intent of the code, even though inspectors may let you do it, especially out there in Arizona, that's not compliant. So this guy came up with this thing, and it's called a wire waffle. And it secures each cable as the code intends it to do. And so I'm like, well, and it's UL marked on it and everything. And I'm sitting there going, well, why would I charge somebody to do a video promoting it? I know people say, well, that's because you're in business to make money. Yeah, but I think it's a great idea. And I like to see people be successful. So Hunter, I'm going to promote this for you and I'm not charging you a squat. I love it. I love the concept of it. Anyway, where was I at? Let's see here. Sebastian, thank you for the wake-up call. Long-time listener, first-time chatter. Doing it out here at UCLA. Awesome, my friend. Well, don't be afraid to chat it up in here. We're all family. Okay, that type of thing. So I'm glad to have you here. Tara, good morning on the Joe Wheeler Lake, smallmouth capital. There you go. I would love to be out on Lake Anna today, bass fishing, but I got to fix the boat. I got to fix the trailer. One of my trailer lights fell off in my trip from Texas to Virginia, and I still haven't fixed it yet. I got it. I just haven't put it on yet. So the moment I do, I'm going to get my wife out there bass fishing because you know how we love to do our bass fishing. There you go. Let's see here. Good morning, Rob. Thank you for being here. Glad to have you here. Look at Googling for PDFs is for the birds. Let's see here. Way better to keep instructions all together with the print. Yes, there you go. Warner Plum, thank you. I've never been questioning it, but it's just curious. Box is 1 1/4 by 1 3/4 by 3 1/4. It's 7.1 cubic inches. Okay. Again, I would go with whatever's more, other than doing the math yourself, which you're not required to do. Okay. So I would just go with whatever's in the listing of the product. You know what I'm saying? Let's see here. Good morning, David. Glad to have you here. Good morning, Edgar. Glad to have you here, my friend. A lot of people out in California join us. I love it. There you go. Rob says, feed the hog. The hog is hungry. Y'all got questions for the hog? I will more than happy to drop them into the hog. Let's see here. David says, questions probably a follow-up. Do the links have a set have to be equal length? Yes. So all of the A's have to be the same length. This is an add-on to the paralleling requirement that we were just talking about earlier for Alejandro, I believe. All the A's have to be the same length. All the B's have to be the same length. All the C's have to be the same length. It's because of even distribution of current. If one conductor in all of phase A, for example, let's say all the reds, if you're connecting those in parallel, means you're connecting together at each end to act as one conductor. If the links are different, then the impedance of that conductor, DC-wise, the resistance would be different. It corresponds, so when you add reactance to that, again, the expanding and collapsing magnetic fields creates a counter-magnetic field, which again can cause resonance in the conductor, which creates reactance. And that has an effect on impedance. And that can change with the length of conductor. So if one conductor is longer than the other, then you're not going to have equal distribution of current amongst that set, right? Or that A phase. And that could be a problem where you could have one insulation melt down where the other does not, and you would create a problem. So they have to be the same length. So you have to take a lot of consideration when you're doing this to make sure that all the A's are the same length, same conductor material, copper or aluminum or whatnot, terminating in the same way, same nature, acting as one. And you have to do the same thing for phase B, but it's totally independent for B. So you could have A be copper, B could be aluminum. That would be okay. Now that would be odd. It's not normally done that way, but nothing says that you can't do that, okay? Just so you know, right? Well, y'all are getting some good nuggets this morning. That's a great question, Alondra. I mean, I was able to, go down all kinds of little things on that one that people ask all the time. So that's pretty cool. That's the beauty of coffee hour. And yes, I'm back to the Diet Pepsi this morning. I've already been up. I was up at 4 o'clock this morning. And I'm all coffeeed out. So I got to change the name of the show. Okay. Pepsi, Diet Pepsi Hour. Tino, there you go. There you go. We'll bring it out of you. Let's see here. Jamal, thanks for joining us. Glad to have you here. Rob, good morning. Is it CEU day? I don't know. If you're an engineer and you're watching, you can get CEUs for it, I guess. Write your own certificate. That type of thing. Let's see here. When boring through framing members, is there a fill requirement for a 3/4 hole like pipe fill? No, there isn't. I do get that question a lot, Manny. A lot of people will ask. They're like, how many NM cables can I stick through a bored hole? And the reality is, if it's a bored hole that's not going to have insulation in it, obviously then it's not going to really affect anything. But if we're just talking fill, the deal is you can put as many cables through the bored hole that can fit without damaging the cable. So if you're putting it through there and it causes the sheathing to rip or damage, that type of thing, then that's a problem. But there is no fill. It's not a raceway, so there is no fill requirement. Now, there are other requirements again when it comes to non-metallic sheath cable. And there's bundling rules and there's all these other kind of stuff that you have to be aware of in the code. But at the end of the day, when you're like taking it through bored holes with thermal insulation, then you're going to it's going to affect the ampacity of the conductor because at that one point, the heat can't dissipate and you create a melting spot or a hot spot. But again, that's with thermal insulation or in through bored holes with thermal insulation. There's other things. And in bundling is where you're running cables together, multi-conductor cables together without maintaining spacing for over 24 inches, which is not going to be the effect when you go through a bored hole because you're going to go through a bored hole, then you're going to space them out again, and then you're going to go through another bored hole, space them out again. So you're not going to have that situation. But yeah, so there's no fill requirement. If an inspector tells you that, they're full of crap. That's just their own personal will. But what they're looking to see is whether or not you're damaging the sheathing. And if your sheathing is damaged, I do make sheathing repair kits, but it doesn't look good on a new installation to start having all this ripped up sheathing, which is not insulation, by the way, it's sheathing on the cable assemblies. That doesn't look good. It wouldn't look good for your inspection, that's for sure. And then it just kind of raises other problems that the inspector could look at. You know what? What's up, Dan? Thanks for joining us. Okay. Cray. Paul's helping Pauls. Hold on, I got something for that. Okay. All right. It's just a QC that does not have a license. So sad. Yeah. That is a problem. Definitely a problem on job sites. Ready to chapter 8 today? Okay. Chapter 8, Adam, is intense. It's single family dwellings. Take your time. When you do your competency review and you get something wrong, take the time to go back and really dissect why you got it wrong. And don't be afraid to ask a question in the Fast Tracks Interact feature that's built into your course. Again, lower right-hand corner, you'll see that little blue cloud. Click on it. You can type your question or whatnot. And if something gets confusing, it can be confusing. Even just simple single-family dwellings can get confusing. Say, Paul, Oh, he's telling Paul he needs some intrinsically safe stickers. I'm sure, Paul, you get with Paul. Paul, put your information, your website or whatnot on here. If it won't let you do it, let me know and I will do it. Okay. Let's see here. Good morning, Jason. Another CMECP in the house. Also owns Jack Radio. Plays the coolest music. That is the music that I listen to. I'm a 70s freak. 70s. I don't know. Jason, do you play 80s or is it just 70s and 60s? Is it hard rock or whatever? I can't remember exactly, but I know that I like it. There you go. So there we go. David says, Parallel Feeders Inspector tried to fail me because my set of neutrals were longer than the set of phases. Again, it's different. So the neutrals get treated differently. You say he tried to fail you. Was he successful? Did he make you do anything? Let me know. How'd you fight that one? Marlon, some inspector does try to enforce rules as though it is a rule, but doesn't present the code reference. So that is another big issue. I can tell you that people all the time say, look, I'm not going to call something out because I don't want to get the inspector ticked off. Look, it doesn't matter. Okay, as it said, as The Rock would say, it doesn't matter. If the inspector gets upset, who gives a crap? If they become retaliatory, in other words, they start nitpicking you. And if you're doing something wrong and they're not really nitpicking, if it's wrong, it's wrong. Even if it's just a nail plate violation, they have a right to call it out. But if they start making stuff up and retaliating, then my recommendation for you is document it. Ask them what the code reference is. And if they can't give it to you, just document it. Keep documenting it. If they keep retaliating because you push back, document it. Then take that documentation to the building official. That doesn't work, go to your first open city council meeting where you can go and talk. Every jurisdiction typically has a council meeting, a city council. If you want to be that stick in the mud, that thorn in their side, that splinter in their finger, all you got to do is go to a city council meeting, open mic, and go up and say, I have a problem I'd like to present to city council about retaliation from a local inspector. If you don't think that that won't perk up some ears, because you know all them politicians are eager to find things, okay? Trust me, that inspector doesn't want that kind of grief. And I was an inspector. I was a head of inspectors. I was the AHJ. I was the engineer for a large municipality, okay? I would get my attention because if any of my inspectors were retaliating, that would be, I have fired inspectors for not following orders. So again, I document everything, okay? I'm a documentation freak. I used to have a little notebook with me in my pocket. I documented everything. It wasn't because I'm an a-hole. It's just I document everything. You know what I'm saying? I'm just saying. Josh, good morning from over on the tube. Glad to have you on the tube. Okay. What do you say here, y'all? Can say morning all you want. 4 a.m. is night. Oh, yeah. It's technically morning, but it feels like right in the middle of the night. I am doing good, Angel. Glad to have you here. Let's see here. All right, we're getting to the end. Sure. Sun's out, fun's out. There you go. All right. Okay, guys, like always, I appreciate y'all. That's why I do take the time to do those intros because it's important to me. It doesn't mean that I have to. It usually is the reason why I'm over an hour. So it's not that I'm not cognizant of that. I know why I'm over an hour. And I have people that post comments saying, why don't you just get to it? Then you need to watch something else, okay? This is for all you out there that say that say, Paul, you take too long, you drag something out or whatever. You need to piss off, go somewhere else. Mike Holt's got some great videos. Brian Jackson's got some great videos. That's not what Coffee Hour is all about. So if you came here just to mooch and learn, and you don't want to say thanks to all the people that come to the show, get your ass out of here. I don't want you as a follower anyway. And do me a favor, unsubscribe. Bye-bye. Bye-bye. I'm not about clicks. I don't care if I have 1 million followers or 1 follower. I'm going to do what I do the way Paul wants to do it. Okay? All right. All right, let's get over here and get to today's lesson and knock out the remainder of what we were talking about. Okay? Again, I don't cater to people. I don't, I do Paul's way, all's ways. All right. So there we go. Let's get back down to where we were. Okay. So here's where we were ended up on yesterday. And I want to end these because these are quick. These are going to go quick. So if you're dealing with something called a ventilated channel cable tray, and by the way, if you don't know what all these trays look like, by the way, then I can go real quickly. Let me just do this real quick. This is an example. So these were ladders. This is like what we call the rungs and the ladders. This is a solid bottom tray for those that aren't familiar with it. This is what we call is a ventilated trough. And you see the bottom, it has little perforated vents in it. Here's what we call, this happens to be a ventilated channel tray. It is much smaller, okay? And it is usually limited in width. And these typically will hold things like Cat5s, communication, signaling, not so much power because they're limited in width. And also you're gonna see in sizing wise, they're typically limited as well. And then of course you have the wire mesh type. And then you have what's called the single rail type. The most predominant we see are ladder and perforated or ventilated trough, okay? That's what we probably see the most, okay? So just kind of to put that mental picture in there, the different things that we're talking about, okay? All right, so if you do have what's called a ventilated channel cable tray, okay, then it says where ventilated channel chambers contain multi-conductor cables, any type can go in there, okay, not specific to anything. It basically tells you to follow 392.22a5a, which is right here, and a5b, which is right here. So it says where only one multi-conductor cable is installed. Again, so you'd be installing this ventilated channel tray for one multi-conductor cable, okay? Maybe it's a very important one cable. I don't know. But it tells us that the cross-section area shall not exceed the values of column 1 of the table right here. So these are your percentages. And what you will notice is that there's only shows a 3-inch, 4-inch, and a 6-inch width type of these channel trays. And it gives you the values in here for fill, okay? That type of scenario, right? So that's the column 1, right? And then a column 2 is saying, well, when you have more than one multi-conductor cable installed, okay, more than one, meaning 2 or more, it says the sum of the cross-sectional area of all cables shall not exceed the values in column 2. Well, column 2, as you see here, more than one. So the 3-inch is 1.3, the fill, and the 4 is 2.5, and the 6 is 3.8. Okay, so that's when you have more than one. So you can't exceed this value. Now, where do you get this value? This is a call, again, like I got call last night. When it says the sum of the cross-sectional area of the cables, that is why I gave you that Math is Fun. Go back and watch that in episode 2 of this cable tray sizing, because then I gave you a URL. You can freeze the screen and write it down. That's how you just basically, if it's a cable, you're trying to find the area of it. And we're going to need the diameter is one, or circumference, but the easiest one is find the diameter of the cable. You get that from the manufacturer. I guess you could measure it yourself. And then you use the formula in order to calculate the area, and that would be your area. Okay, so don't get confused when it says cross-sectional area. It's basically the approximate area of that cable, just like it would be for a conductor, if you will. And you have to do a little bit of math. But most of the manufacturers, if you request it, will give you this information. But it's not hard. And if you're on an exam, just write that formula down. And again, just go to our episode we did, number 2. You can scroll through it, and you will see where I gave you the reference to Math is Fun. Or you can do Google search. You can go area of a circle, math is fun. And you'll probably get that little calculator. And it just makes it nice and nifty and easy. I can't use that in an exam, but what it does is it does give you all the formulas that you can write down so you could do that. In the real world, again, contact the manufacturer or measure it yourself and apply the formula, then you can be all right. But anyway, that's how you do it. So that's straightforward, and that's basically treating it the same way we would do a raceway with single conductors in it, right? Same thing, cross-sectional area. Same thing here, we're just gonna do it as a cable, okay? Now, they also make these in solid channel cable trays, right? And then that's the scenario. This is the exact same thing we just did. It's just down here is when you have one multi-conductor cable installed, again, of any type, okay? One, and then you use the cross-sectional area of that cable shall not exceed the values in column 1, okay? And here you see in these, they get a little bit bigger. So they're traditionally standard, a 2, 3, 4, and 6. If there's any larger than that, and I don't know the standards, by the way, for these type of trays. I'm not a cable tray guy to know their standards. But if they happen to make one that's larger, I would think that the manufacturer will give you the information. Okay. And you can utilize the information that the manufacturer gives you. Other than that, you're going to pull from these tables. Okay. So again, I'm not a cable tray manufacturer, but I am sure that they will give you more information that you care to want when it comes to cable trays. If you reach out to them, if it's something that doesn't really jive with what's in the NEC, that type of thing. Okay. It does, again, just because it's not in NEC doesn't mean they don't make it. That type of scenario. Okay. Remember, this is a minimum safety standard. All right. So that's that. And then, of course, in this one, it says where more than one multi-conductor cable is installed, the sum of the cross-section area of all the cables. And then when you see sum, it just makes the adding them up, how many you have. Okay. And adding their cross-sectional areas up, and they cannot exceed the values in column 2. And here you see, again, as we said, here's the values in column 2. Okay. All right. Pretty straightforward. And we talked about this. So remember everything that we talked about. There are stickers typically on the side of a cable tray. They usually will have markings on the side of them, depending on what they're used for. If they're going to have service conductors in there, and there you go. So here's your markings that you're talking about here. Cable trays containing conductors. This is if they're over 600 volts. Then here's some markings that you got to have, that type of thing. So yeah, typically you're going to have all types of markings and stuff on the side of it. If service conductors are in there, then there's requirements that to have it say that there's service conductors in there, obviously, and that type of thing. Okay. Let's see here. What is this? Oh, let me get back to comments here. What did David say? 10 500s in the main switchgear. Pull the code book out. Argue the wording of the article. The set of phases and neutral need to be equal length, not all. Yep, just all the neutrals need to be the same. All phase A need to be the same. All phase B need to be the same. All phase C need to be the same. They don't all need to be the same. Okay? Because it's all about the distribution of current. Once you size the conductors, if you're running parallels and you're trying to achieve, let's say, 1,000 amps, and let's say you have multiple A's of, say, 4-aught until you get to 1,000 amps, they have to all be the same length for A. Same for B. Same for C. Same for neutral. Okay? But it's very specific to those sets, not overall. Okay? So if an inspector tells you that all of A's, B's, and C's and the neutrals all have to be identical length, he's full of crap. Okay? He doesn't know what he's talking about. Okay? You tell him Paul said, you don't know what the hell you're talking about. All right, so let's go down here to ampacities real quick and nail these out. Okay, this is really simple stuff, so I will kind of just nail out. So let's talk ampacities. Now, firstly, let's talk about ampacities of cables in a cable tray. We'll do that first. And remember, we're doing this backwards because on day 1 we talked about single insulated conductors and single conductor cables and single insulated conductors, right? So now we're going to go the other way. We're going to talk about cables in general. So multi-conductor cables being installed in cable trays. And at the end of the day, that's what a cable tray really is for. Even though we have some allowances to put single insulated conductors and single conductor cables in a tray under an industrial establishment allowance, cable trays are primarily made for cables, right? That's hence the name cable tray, right? It's a supporting system. It's not a raceway. So if you look at it right here, it says the ampacity of multi-conductor cables nominally rated 2,000 volts or less, and we're not going to do medium voltage on my show. Okay, not my bailiwick, not my thing. Even though Prismium has medium voltages, I'll leave that to the Prismium, their people. I don't do that. I can answer questions on it, but I'm not going to do that in my show. I'm going to talk about what we use in a day in and day out, typically 2,000 volts or less applications. Okay, installed in accordance with the requirements of 392.22a. Now, what that right there means is that's everything that we did in when we did day 2, okay, or part 2, when we determined how and we sized the tray, whether or not the conductors are going to be in a single layer, whether or not the cables in a single layer, whether or not we have the larger ones, and then we have the smaller cables that are under 1,000 kcmil. we're saying that if we install the if we install the cables in that tray in accordance with 392.22a, so you watched part 2 and you installed them properly, then it says shall be given, the ampacity shall be based on 310.16 and table 310.18. 310.16 is our basic table for ampacity. So that's the first thing I tell folks right off the bat. When it comes to multi-conductor cables in a cable tray, for the most part, you're going to be using 310.16 ampacity values, flat out, okay? Now, the 310.18 is different types of cables, right? So if you go look at 310.18, and I'll pop that up here, I mean, this is dealing with, okay, ampacity of insulated conductors and raised for a cable. This is the ampacity here, as long as you meet these conditions, okay? And these have temperature values that are in 40 degrees C, okay? And these are not typically what we're going to use as a normal installation. Our normal installation for you are going to be THHN, XHHW type conductors inside of cables, the normal cable allowance, however. So, but it is important, and I don't know if this will go back. No, it's going to make me jump all the way down again. Okay. I just think it's important to understand its premise here. And it's saying, because you do have some applications where you'll have some of the cables, multi-conductor cables, where you'll have those higher temperature values for the insulation, okay? But for the most part, and I think what I find the most for engineers, design professionals, and exam prep folks is that one of the key takeaways is you're really going to be doing everything from table 310.16 ampacity for these cables, okay? So now let's get down to some of the nuances here. Again, we're talking multi-conductor cable, A. Okay, now here's where it tells you subject to all these right here, which are these down here. Okay, and of course this little reference right here is that nifty little one that says if you have two different ampacities based on the condition of use, then you have to go with the one that's the lesser. But we do have an exception in there if the one that's the lesser, that has the lower ampacity due to, say, higher ambient temperature, maybe, you know, as long as it's 10 foot, 10% and doesn't exceed that, the lesser of the two, then what happens is you can ignore the one that impacts the conductor and makes it less current carrying, okay? That's what it's saying. So it is in play, okay? That allowance. If that confuses you, you need to go back and watch that episode on that. But just remember, to keep it from being confused, these are the ones that typically you're going to play the role in when you're doing the ampacity for these cables, multi-conductor cables inside of a cable tray. Here's the first one, A. This is this right here, A. It says, the adjustment factors in 310.15C1, and again, that is the one where you what? Bundling, okay? That's the bundling rule, okay? Shall apply only to multi-conductor cables with more than 3 current carrying conductors. It says adjustment factors, the ones we just talked about right here, these adjustment factors shall be limited to the number of current carrying conductors in the cable and not to the number of conductors in the cable tray. Okay, so that's important first, right? Because that is basically telling me that I can, as long as my multi-conductor cable does not have more than 3 current carrying conductors in it, that I can ignore 310.15C1, right? I can just say, forget about it. And if I have multiple cables inside of this cable tray, and again, I'm meeting the requirements of 392.22a as far as how they go in there, right? If I meet that requirement, then it's saying, you know what? I don't have to take any consideration about the adjustment factors at all as long as my cables don't have more than 3 current carrying conductors in it, right? And the other thing to remember here is that this is, again, not applying to the number of cables itself inside of the cable tray. That's huge because normally if we were to bundle cables, right, and you look at 310.15C1, then if we bundle cables without maintaining spacing for what? Over 24 inches, then we're going to have to apply what? An adjustment to that. Now, at the end of the day, I will remind you something, that this does not, even though it says don't worry about it if your cables don't have more than 3 current conductors, you don't have to apply the adjustments, and it applies to the cable and not the mass of cables inside of it. You still got to meet all these rules here. So these are going to help limit it anyway, because it's going to say whether it needs to be 1 layer. This is going to say whether or not there's a certain amount of fill that can be in there. So all that plays together, okay? So don't freak out about it. But what's really important in this scenario is that it does not negate the fact that you may have to make an ambient temperature correction, okay? That still may be in place. So don't think that that's gone, because that still is there. That always is there. So it doesn't remove that requirement, but it's specifically removing the number of current carrying conductors as long as each of the cable doesn't exceed 3 current carrying conductors, okay? And it may or may not exceed 3 depending on whether or not, let's say you have a tray cable with 4 conductors in there, three hots, if you will, and a neutral. If that neutral is considered a current carrying conductor, then guess what? It will exceed 3. And if that's the case, then 310.15c does apply. Make sense? Okay. So you only get to remove this if the cable doesn't have more than 3 current carrying conductors. If it does have more than 3 current carrying conductors, then you must take into account 310.15c1. Okay. All right. And again, this last statement here only comes into effect if you meet the first statement here. Okay. All right. B. Now, B says, now where the cable tray is continuously covered. So again, this one, it implies that this one is an uncovered application. So an uncovered cable tray. Good morning, Jason. Uncovered cable tray. This one is specifically talking about a continuously covered cable tray of a certain length. So it says, now look, it says where a cable tray is continuously covered for more than 6 feet with a solid unventilated cover. And where we maybe have something like this? Well, you may have something like this where you have a cable tray that is rated, let's say, for a hazardous location. You may have a situation like this where it's rated for an outdoor use and it doesn't have any openings in it. Again, there's many different types of trays. But if you do have a cable tray that is unventilated cover, okay, talking about the cover because heat rises, okay, then it says, okay, look, if you have this cable tray and it is continuously covered and it's more than 6 feet and it's covered with a solid unventilated cover, okay, that's all it's talking about. It says that if that's the case, then it's not over 85% of the ampacities in 310/16. Okay, so whatever the ampacity is for those cables in that cable tray, that if that's the case, then what you have is whatever the ampacity is, you can't exceed 95% of that ampacity. Okay, so that conductor now doesn't have the same ampacity; it's reduced. Okay, now it's and also that's going to be applicable to both, whether 310/16 is in play or those conductors that are being used in that cable that are 150 degrees, for example, not 90 but 150. Then you would be using table 310.18. Either way, you're going to be limited, okay, to 85% of that ampacity. Okay, now. There's something I need to point out here. Even with this in play, don't forget the charging statement said this. This is really important for the engineers who's designing it and inspectors who look at this and say, wait a minute, you can't exceed 85% of the ampacity right here, right? But if this rule is in play, and I'll show you this rule, here's where it says where more than one ampacity applies to a given circuit length, the lowest value shall be used. In our case, it would be if we were using the ampacity based on the conductor, but we had to reduce it so that it doesn't exceed 95% of the ampacity of the table, then that is a lower value compared to the portion of the conductor of the cable that isn't underneath the cover. Well, if that's the case, you would go with the what? You would go with the ampacity that's then up to 95%, right? But then you have this allowance here. Okay, And this allowance says exception where the different ampacity applies to portions of a circuit. It says the higher ampacity shall be permitted to be used if the total portion of the circuit with lower ampacity, that is that 6 foot, by the way, does not exceed the lesser of 10 feet or 10% of the total circuit, okay? So important as a design professional, maybe not for us, maybe you don't run into this very often, but if it's only 6 feet of it and you're restricted down to 95% of the ampacity, if it's only 6 foot, then it may be that that may help you. 310.14a2 and the exception may help you ignore that small portion. But if you look here, this just says more than 6. So it could be 20 feet, could be 30 feet of covered. I don't know. And that's obviously, then if that's the case, then 310.14a2 and the subsequent exception, it's probably not going to help you any. But I always like to point those things out for the design professionals because it may save your day. It may be that your cable tray with an unventilated cover only goes through a fire penetration or through a fire rated wall or something like that where it has to be sealed. And you may have one piece that hooks into the tray that's designed to go through that penetrated wall, and maybe that's only a foot long or 2 feet long and that type of thing. Well, and it's solid. Well, it's not more than 6 feet. That doesn't make a difference. But what if it was penetrating through it and it was 6 feet? Then this exception in 310.14a2 may be a big benefit to you. It may help you. Okay, so I like to point those things out whether you use it or not, but that's why it makes the statement up here because it is very much still in play. Okay. Next one here, when it comes to ampacities, again, we are talking multi-conductor cables. It says where the multi-conductor cables are installed in a single layer, okay, in an uncovered tray with a maintained spacing of not less than 1 cable diameter between the cables. And y'all saw me talk about that the other day, and I said I would allude to it as far as ampacity today. But that is a situation, and we do have a picture of that, in case everybody's like, okay, what are you talking about? This is saying, look, if you take those multi-conductor cables, okay, and you install them in a single layer, okay, and you maintain spacing of not less than 1 cable diameter of the cables you're using, of 1 cable diameter between these cables, okay, so you're maintaining spacing, right? Got a cable, you have a gap, that's the width of the cable, you have another cable, and you have a gap, and of course, you remember, we're sizing our cable tray to accommodate that, so we're adding the width of the diameter of the cable, plus the diameter of a space, which represents another cable, and then to have another cable, so you're taking all that into consideration to find your minimum tray width, right, on the interior. If we do all that, it says the ampacity shall not exceed the ambient temperature corrected ampacities, which means that you still may have to do an ampacity based on ambient temperature, but you get to ignore any of the requirements under 310.15c1. You don't have bundling requirements. You don't worry about that because you are spacing. And it says we're not more than 3 insulated conductors, okay? Okay, we're not more than 3 insulated conductors rated 0 through 200 volts in free air in accordance with 310.14b. Okay, so this one is important to explain because I'm going to tell you what I'm going to tell you first. I'm going to tell you that basically this is saying for the layman, okay, and I'm going to show you how this would apply to an engineer who wants it. I get these calls all the time, and the engineers go, Paul, somebody made a mistake. And we're willing to space these cables out in a tray. And I screwed up as an engineer that I designed this. I need to get more ampacity out of these conductors. So I need to take the benefit of free air, which remember, the charging statement for this was use 310.16. It wasn't to use the free air in 310.17. Okay, there's where people get confused. Just because it says free air in here, it's not meaning use the table 310.17. Here's what it means. And there's an example of this. If you go look at the informative Annex B, there's a table. So what this means is, you know what? An engineer under engineering supervision can come up with an ampacity value for these conductors that may be higher than what's given in table 310.16 for the conductor, and it doesn't matter to the manufacturers of the wire. We don't care. We like to follow 310.16, but if an engineer wants to use a kind of a Near-McGrath type of calculation, they want to use the informative Annex B values, they want to do all that, and they're willing to put their stamp on it, we're okay with it because they're the ones that will be responsible. If something happens, the installation melts down, something fails, manufacturer's going to go, you did it, I didn't do it. We recommend you follow 310.16. Okay? But as an engineer, you do have that prerogative, right? And so when I show you this, I'm going to show you this free air doesn't mean you go use 310.17. It means, boom, it means under engineering supervision that an engineer can use this formula right here, okay, to calculate the new ampacity of this conductor, okay? Also, based on that, they can come down here and use an example that's given in the table. And I'll do this. See this table right here? This is not enforceable. This is information only. But you see how it talks about where it's not more than three, not three current carrying conductors. It says not more than three insulated conductors. And it talks about based on free air, based on 40 degrees C, and then based on these types of cables. I want you to notice something. If I go down and look at the ampacities, right, you'll see, for example, here under the 75 for copper, you'll see that this is good for 245 for a 4-aught, or 3-aught's good for 213, okay? This is based on those conditions. That can only be done by engineering supervision. And this table is just a shortcut based on the Near-McGrath that the engineer can go to. Typically, they're going to use their own calculations in a software like ETAP or something like that. Most of the engineers that I know aren't going to touch that. Most of the engineers that I know are just going to base it on 310.16. But that's there for them to do this if they would like to. And you still have to meet the caveats of spacing. And that would be an example right here. So remember, the tray still has to be, we size the tray, right? In 392.22a, right? And again, the tray has to be at least the width of the cable plus the space equal to a cable. If they do this, then the engineer can come up with their own ampacity values for these conductors, and it may get them out of a bind, but they're responsible for it. What this means to me and you, it means that if I do this, then I can ignore anything about 310.15c1 for the number of current carrying conductors. As long as I have, more than 3 insulated conductors in there, I can ignore all that, which you should be able to anyway. I can ignore all that, and I can use the ampacity straight from the table, 310.16. That's how I would prescribe this to be done, okay? All right? Okay. All right. Anyway, let's go on. Okay, now let's talk about the ampacity for single conductor cables. Okay? When you can do it. Now, we talked about this in part 2, when you can do it, right? And so let's just assume you've done it and you're putting them in the tray. All right, so single conductor cables. So the ampacity for single conductor cables and single insulated conductors, by the way, which is, again, my oversight when I had these things changed. I did not go through and try to fix everything in the code in that specific article. So that's on me. All right, so I will bear that burden. Okay, so anyway, so the ampacity of single conductor cables or single insulated conductors for the most part here shall be permitted by 310.14a2. And if I click that for you, again, this is just talking about, again, there's that rule where it talks about the ampacity if you have 2 different values that you use the lower one. But this reminds you that the exception is in play because it doesn't remove the exception, okay? So this is still in play when it comes to cable trays. That's a good thing, right? It says the adjustment factors in 310.15c1 shall not apply. Important stuff here. We're talking about single conductor cables and single insulated conductor. Shall not apply to the ampacity of cables in cable trays, okay? That's the first part, cables in cable trays. Next, it says the ampacity of single conductor cables or single conductors cabled together in a triplex, quadplex, and so forth. I don't see anything other than tris and quads. I can't think that I've seen any more of that. I'm sure they're out there, but that's what it is. Okay, so it says the ampacity that applies, okay, in this scenario, the ampacity of single conductor cables and single conductor cable together in triplex, quad, and so forth, nominally rated 2,000 volts or less, shall comply with 392.80 A2A through A2D. So they have to apply here. Okay, so here. All right. Here, 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 and here. All right, so we're going to go each one of these pretty straightforward. Okay. Now, this is one of those things like here, let's do this. Let's take this really quickly. Okay, I'm going to copy this. Let's try something real quick. Let's do, because I know I'm going to get this question if I haven't gotten it yet. Hold on here. Bear with me, guys. Let me log in. Let's feed the hog. I feel like breaking the hog today, because I know I'm going to get this question. So let me see if I can go right here. Okay, there we go. Okay, really quickly here, I'm going to go down here and I'm going to paste, okay. So let's see here. Please explain the following. And I'm going to paste this in here. Watch this, guys. Place. And are you saying that 310.15, watch this, C1, we're feeding the hog, doesn't, sorry guys, I can't see it because my mic's in the way, doesn't apply to single insulated, see how I'm playing with it, insulated, I gotta move this mic. Single insulated conductors in a cable tray. All right, y'all see the question, right? I don't know what your 2023 is going to say exactly the same thing as I showed you on the screen, Tino. Otherwise, you got one of those counterfeit books, because the link is exactly, you're looking at the wrong code reference if you are. Don't get confused with the different ones, because there's an A's and B's. Okay, so I'm going to type this in. All right. So let's see what the hog says. Okay. All right. Here's what it says. It says the statement you provided refers to specific conditions under which the ampacity of single conductor cables and cable trays can determine according with the National Electrical Code. Okay, yada, yada, yada. All right, ampacity single according to blah, blah, blah. Okay, I got that. Adjustments. 31050 typically requires adjustment factors to be applied to the ampacity conductors when there are more than 3 current conductors bundled together, which can lead to increased yada, yada, yada. However, the statement you provided indicates that these adjustment factors do not apply to the ampacity of cables in a cable tray. To clarify, 392.80A specifically addresses the ampacity of conductors in cable trays. It states that the ampacity of a single conductor cable installed in cable trays is determined without applying the adjustment factors in 310.15C1. This is because cable trays provide a different environment for heat dissipation compared to other types of installations, and blah, 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 blah. Therefore, for single insulated conductors in a cable tray, the adjustment factors in 310.15C1 do not apply as per NEC 392.80A. This allows for potential higher ampacity ratings for conductors in cable trays compared to other installations where adjustment factors would reduce the allowable ampacity. Wow, that's a lot, but this also is true, and it also gives you code references, right? So again, we had to feed the hog today, right? So we fed the hog, okay? So this is a good example of feeding the hog. Now, what can make this, again, a little confusing is the fact that of the way it says cables and it doesn't say single insulated conductors. So it will lead people to say, well, this doesn't apply to those single insulated conductors. Well, how in the hell do you determine an ampacity if you're allowed to install them in an industrial establishment and we're allowed to put them in a tray and they got to have an ampacity? If this didn't apply, then what's the ampacity of the conductors in that tray? So that's why it's, one of those things that you're just gonna have to realize that that's what it's talking about. Okay, single conductor cables, or here it says or single conductors, that type of thing. Okay, all right. Anyway, so that's that. So we don't have to apply 310.15 C1 to that application. Okay, now let's look at the ampacities. Now, why is that? Because we're going to have other requirements that's going to reduce the ampacities of the conductors anyway. Okay, all right. So here is the thing. So let's look at the first one. All right. So it says we're installed in accordance with the requirements of 392.22b. Okay. So remember that 392.22b, that was the rules with the conductors inside of the cable tray. We talked about this. This is part of part 1 of this series. I'm not going to reiterate that because I'm already over an hour. So go back and watch part 1. So this assumes we're installing them in accordance with the rules, whether it's a single layer, whether or not it's based on fill, which you could stack, but it's based on fill. However you do it, we installed it in accordance with this requirement. Okay, so that's what that's all about. So go back and watch part 1. Now, it says if we did that, we followed the rules for putting these conductors in the cable tray, then it says the ampacities for a 600 kcmil and larger, single conductor cables or single insulated conductors in uncovered cable trays, okay, just a normal open uncovered cable tray, like whether it's a rung style or ventilated bottom or ventilated trough, it's open, right, uncovered. It says the ampacities shall not exceed 75% of the ampacities in table 310.17, okay? Now here you go. So why is this not using 310.16? Because you're able to use the benefits of 310.17, okay? And if you hit 310.17, I'll just click on it. Here, you can see that 310.17 is about ampacities for single insulated conductors in free air. So they're allowing you to utilize the ampacities here rather than 310.16, okay? Now, again, I'll remind you, this table, just like 310.16, is based on 30 degrees C, 86 degrees Fahrenheit, okay? You'll notice that the conductor insulations are the same, 60, 75, and 90. Everything else is the same. You're just given permission because these conductors are going into a cable tray, and it assumes you're installing them under the guidance of 392.22b, which has all these rules for how you can put these conductors in there. Once that's done, it's saying, okay, well, because the fact that it's open in the top, because it's typically going to allow heat to dissipate better, it's going to allow it to circulate, we're going to let you use a little higher ampacity. And that's what you get down here. And I will emphasize it. For example, if you get down here, look at this 10 gauge. It's 50 amps. Now, don't forget there's still an asterisk. So asterisk is still going to limit you to the small conductor rules, by the way. So don't ever lose sight that you're still going to have to follow the terminal limitations and things like that in 110.14c. So don't get all excited, okay? Still got to follow the rules, all right? But at the end of the day, you can't do it from this higher ampacity, okay? And let me see if it gets me back where I'm at. Okay, so there we go. So, but what you're going to do is you take that value under the 310.17 and you're going to be eliminating it to 75% of that value. And I don't know how that equates to the 310.16. That'd be a fun little thing for folks to do. Say, look, if I just use 310.16, which you can't go wrong with, what's the ampacity of this conductor? But what is it at 75% of the value in table 310.17 and see? Okay, that type of thing. All right, so there you go. So there's that. Now it says now where cable trays are continuously covered more than 6 feet, that looks very familiar, right? Then it says with a solid unventilated cover, that the ampacities for 600 kc mil and larger shall not exceed 70% of the ampacity in those tables. Okay, so if you're doing 6 feet or more than 6 feet, then guess what? Now you're going to be having a problem. You're going to be saying, well, wait a minute. Now I can't exceed 70% of whatever the ampacity. So go to the table, go to 31017, take the ampacity, and then reduce it, and take 70% of that. And you can't exceed that value. So without even using 310.15c1, this already, yeah, Terrence, yeah, don't buy any NECs from Amazon's. Don't buy NECs from eBay. If you think you're getting a deal, you're not getting a deal. Usually they're counterfeit. Be careful on buying code books from people on TikTok or anything like that. I have seen my share of counterfeit NECs. Buy it from the source. Buy it from your local supply house. It's not worth saving 20 bucks, 30 bucks. It's not worth it because there are code books out there that won't have the same language in it, and it can be that you have a counterfeit, and you don't want that. Spend the money you need to spend to get the proper tools. NFPA, support NFPA, buy them directly or somebody, or buy them at your supply house. Again, that type of thing. All right, so that's what you do there. Now, what about other sizes? Okay, well, we're installing according to the requirements of 392.22b again. So assuming you're putting these conductors in there, okay? Now, your handbook should be exactly the code. The commentary is different. The code part, not the blue part in the handbook, the code part should be exactly the same as Link because they're both from NFPA. If your code portion is different, you've got a counterfeit book, my friend. All right, so now, we're installed in accordance with these requirements. The ampacity for 1/0 through 500 kc mil single conductor cables in an uncovered cable tray shall not exceed 65% of table 31016. So you see why we do not have to worry about 310.15c1 here? Because you're already going to be reducing the ampacity of these conductors, okay? So it's 65% of 31017, okay? And again, you have that same scenario here where if you have a continuous covered tray, right? And it's 6 feet or more of it's covered by a solid unventilated, right? Then in that case, if it's 1/0 through 500, then you can't exceed 60% of the ampacity here. Now, again, I haven't looked at it but to see what it would be under 310.16. But the one thing to remember is if you're using 310.16, then you don't get to follow the rules here. You don't get to ignore 310.15c1. This tells you to ignore it because you follow these rules. You don't get to pick and choose, folks. This is not an a la carte, okay? Not an a la carte. You with me? That's so important. I got to say that again. You get to ignore 310.15c1 if you're following this rule. Not if you're saying screw this rule and you're going to follow the ampacities in 310.16. If that's the case, then you have to follow all the rules that are associated with it, okay? Just want to make it clear. All right? Okay. Just want to be clear. All right. So this is only if you're following these rules that you get to follow this allowance, okay? Right here. All right. So next one, right here. How about C? C says a single conductor are installed in a single layer. Okay. So you're just putting conductors in there. Single layer. Okay. It says in an uncovered cable tray. Great. It says with a maintained spacing of not less than 1 cable diameter between individual conductors. Okay. So this is what's the problem with the code right now, guys. And I'm going to do my best to fix this by 2029. Look at this one statement. Look at this one statement. This says we're single conductors in a single layer. Then it says maintains not less than 1 cable diameter. So it talks about using single conductor, and then it talks about it being a cable. Then it turns around and it says between individual conductors. Guys, I as a code expert, and I will speak on behalf of code panel members, we get so focused in tunnel vision, we're not supposed to go to these meetings and change the code. We're not supposed to just go willy-nilly. You're supposed to submit things like public inputs and things like that. I let you down, okay? Because as a code guy who submits these things, if I go into an article like that, and I'm just saying this to all of my fellow code folks out there that submit stuff for code proposals, we get such tunnel vision, okay? We get so tunnel visioned that we're trying to fix one thing and we don't realize that there's repercussions elsewhere. Don't blame the code. And I'll take the blame for this one because I should have stopped and went through there and tried. And at least let the code panel tell me, Paul, you're off base. We don't mean for this to apply to single insulated conductors. If that's what the code panel means, if that's what code panel 6 means, if that's what they mean, then they need to tell us, because in that one sentence alone, it went from 3 different things. It went from one to the other, right? And always remember, Brandon, when it says diameter, it's not talking about volume. Diameter is a physical property. Volume is a calculation to come up with a volume. Anytime it says diameter, it's the physical property, the diameter across the conductor, okay, or across the cable. If it says the area or cross-sectional area, it's talking about the volume, the area, and you have to do a calculation. Don't let that confuse you. If it mentions diameter, it's a property, okay? You know what I'm saying? Okay. Let's get back where we're at. Hopefully that clears that up. So, but in this one, it says this 3 freaking times, and it's frustrating because it talks about single conductors in a layer. Then it says they have to have a spacing of not less than 1 cable diameter. And you're saying, well, Paul, a cable is different than a single conductor. Not in this context, because if it says I got to have it not less than 1 cable diameter, what freaking cable do I use? What do I use? Is it got to be a diameter of 1 inch, 2 inches, 5 inches, 6 inches, half inch, quarter inch? You get my contact? You get what I'm saying? You hear me? Right? So in this scenario, well, Chapter 9, Table 5 is only going to give you certain sizes of conductors, okay? It's not going to give you all the sizes, okay? So again, it might give you 1/0, for example, for a THHN, but it's not going to give you all. It might give you up to 1,000 kc mil, but it's not going to be larger than that. And you could have larger than 1,000 kc mil. So then you got to go to the manufacturers, right, and get that information. So, but if we're doing it in real terms, let's say we're dealing with the normal stuff, like I said, 4/0 and 250 kc mils and 500 kc mils, then you can get the approximate diameter of a conductor by going to Chapter 9, Table 5. When you get something that goes outside of that table, then for like the really large conductors in a tray, and again, that can apply because this says for 1/0 and larger doesn't put a height ceiling on it, that type of thing. But if we go to 310.17, for example, I'll just show you. You see here, it goes up higher than that. Okay, I mean conductors right here, they go up higher. So, and of course down here, the kc mils, right, can go up higher. You've got 1,200, 1,500, 1,750, 2,000. And so those aren't typically given in there, that type of thing, right? So just kind of things to keep in mind. Where was I at? Let me get back. Let me get back to where I was, because I am running over again today, as usual. I don't think I can ever stay on time, but most of you don't mind that I run over. That's okay. Now, in this scenario right here, by the way, this is basically saying that as long as I space them out, and I have if I had, let's say 500 kc mils. So I have a 500 kc mil and I space it the diameter of another 500 kc mil, and then I put another one beside it, then I space it again, a width of a 500, and I put another 500 kc mil, and then I have another space equivalent to a 500, then I have another one, and of course that's going to dictate my tray's width, right? By doing this. Let's assume I do that, then it says, you know what? Then I can use the ampacity values in 310.17, okay? Right? I can use those values. And because of these spacings, you'll notice something. I don't have a percentage. I don't have anything that affects the ampacity of the conductor, folks. It's not reducing it. I can use the ampacities from this table. And guess what? I also get to ignore 310.15c1. That's a beautiful thing for right here if I design it that way, right? But here's the caveat. What if, okay, what if it is not it's a solid bottom cable tray? It's not a ventilated bottom or a rung style. What if it's not? Uh-oh. Well, then you got this right here. It says, uh-oh. See all this nifty that lets you just use the pure amp. Remember, you're still going to be limited to terminals. So don't ever forget that. This doesn't give you the carte blanche to use the 90-degree rated ampacities, right, in those tables. If the terminations are only rated 75. Y'all know that, right? I don't need to tell you that. You should know that, okay? However, it does say down here for solid bottom cable trays, it says the ampacities of single conductor cables shall be determined by 310.14b. And again, that is engineering judgment, and they will use calculations, okay? So if you happen to have a solid bottom tray, then this right here can be a problem. And you basically, if it's a solid bottom, and the engineers will have to do a calculation for that, okay? Because you're not going to be able to have the heat dissipation. It's solid bottom. It's going to hold the heat in, that type of thing, okay? All right, so this is going to impact the design of it, okay? Right here. All right, now lastly, D. D says, all right, it says now where single conductors are installed in a triangular triad, I'll show you a picture of that, or a square configuration, 4 conductors, basically it's square or like diamond configuration, in an uncovered tray, so there's no cover on it, so we're allowing heat to ventilate, okay? It says, with a maintained air spacing of not less than 2.15 times one conductor's diameter, and it's going to be the largest conductor's diameter amongst the configuration, okay? Whether it's 3, a triad, or 4, the diamond square shape. You take the largest conductor in the configuration, okay? And you take that, and basically it's going to be 2.15 multiplied by the OD of the largest conductor in that configuration. And that's the spacing between the next configuration of triads or quads or whatnot. I'll show you an example of that. Now, if that's the case, and you do that, and you follow these rules in that tray, okay? You follow the rules in the tray, then here's what it says. It says, the ampacity of 1/0 and larger cables shall not exceed the ampacities of 2 or 3 single insulated conductors rated 0 to 2000 volts supported on a messenger in accordance with 310.15. So why is that important? Okay, so if I install it like this, right? And these are connected together, they're plexed together, or they're configured together in this case, this is a triad, right? Triangle configuration. So if you want to do this in here, and you're say an engineer, and you're like, okay, I'm putting plex cables in there, twisting them together, and I need to get higher ampacity. Okay, I can buy whatever width tray I need in order to be able to do this. Okay, the tray's uncovered. Gotcha. I need to get a little more ampacity out of these conductors. Okay, well, what's it saying is, well, if it's in a triad or quad, you take the largest conductor in the configuration, you take it and you multiply 2.15 times the OD, whatever this is. You get this. You can get this from Chapter 9, Table 5. If it's larger, you can get it from the manufacturer's product sheets, whatever you get, and you do the calculation. 2.15 times the OD, that is the space that you have to have before you put your next configuration in. And then you have the same space between that and the next one. You with me? So this could be a configuration that's running in a tray, and you're basically spacing them out, okay? If that's the case, and you do this, okay, then you get to use the ampacities, and I'll show you something in this table. This table right here, okay, is ampacity of conductors. You can't see it because it's too low. But basically, this is ampacities, and it sucks. I'm gonna make sure y'all can see this. So hold on for a second. I need to change this for you folks real quick because I need you to be able to see this. Hold on for a second. Let me see what I can do. Hold on, folks. Bear with me, guys. I'm gonna change this on the fly because I don't like the fact that you can't see this table. Y'all know how I am. I'm anal about this kind of stuff. So I like to make sure that you can see it. Okay, hold on. And you never know because I got so many configurations of pages. So here you see here, this is the ampacities of conductors on a messenger. And it can affect the ampacity of the conductor. For example, I come down here and we just look at something that we're familiar with. Here's a 4-aught, or here's a 3-aught right here, 3-aught copper. 3-aught, so the copper over here under the 75 right here would be for 3-aught is 245 amps, okay? Now, under 310/16, what would that be? Just so you can, 345 under 310/16, let's compare that 3-aught. If you look down here under 3-aught here, it's good for 200. So you're getting extra amps based on messenger. Now, as far as the code's concerned, is it a messenger? No, it's not a messenger. But the code is specifically saying, hey, if you do this way, right, you configure it this way, then what I'm going to do is I'm going to let you do this. I'm going to let you apply it like it was on a messenger, right? And again, that's what it looks like. And it's not on a messenger. And a messenger, if you don't know what a messenger is, it's a supporting component, like a steel wire that supports from point A to point B overhead. Or you can have what's called like a ACSR, which is a supporting neutral, which has a built-in messenger. Not the same here, but basically we're talking about something that's going to be supported on a steel framework, okay? And if that's the case, it actually hangs from it, but it's typically in the air, that type of scenario. So basically, it's going to let you use that ampacity under that condition, okay? But you have to lay it out like that. That's the only way you can do it. And sometimes when you're in a crucial situation and the tray has already been defined and the engineer is already designing it, and you go, oh my craps, I don't have a conductor that can handle ampacity, even if it's a couple amps under, then a savvy engineer may look at this and say, well, here's what we're going to do. We're going to do it like this, and this is what you need to do, and this is how you configure the actual conductors, you know, that type of thing, in order to get me a little more amps out of it. But at the end of the day, guess who's responsible at that point? If they give you that kind of direction, then the engineer is responsible for that. Okay, you with me? Just want to make sure that we're all on the same page when it comes to those engineers, okay? All right, so that's D, all right? And the last one down here is basically when you have multi-conductor cables and single conductor cables in the same cable tray, assuming they have the same voltage rating and all that kind of stuff. All this is saying is you calculate the ampacities for the multi-conductor cables one way. You calculate the ampacity for the single insulated conductors or single conductor cables another way, okay? And then when it comes to how they go in the same tray, that you do the fill requirements for the single conductor cables and the fill requirements for the multi-conductor cables, you have to make sure that combined, the fill requirement does not exceed 100%. So 50% of the fill for a tray could be made up of multi-conductor cables, and the other 50% is made up of single insulated conductors or single conductor cables. Combined, they can't exceed 100% of the fill. But as far as ampacities go, you calculate the single insulated conductors just like we did separately from the multi-conductor cables. You do them separately, okay? And that's all it says to do, all right? See, that's what it says right here. It says, where a cable tray contains a combination of multi-conductor and single conductor cables, the ampacity shall be given in 392.80A1 for the multi-conductor cables. So that's the ampacity for those. So do like we just did today. And then it says, and use 392.80A2 for those single conductor cables, okay? And you can do them separately. They can be in the same tray, provided you have these following conditions. And that means you have to follow 392.22A for the cables. You have to follow 392.22B for the single insulated conductors. Whatever their fill is and whatever their fill is for those combined, they cannot be more than 100% of whatever that tray's allowable volume is, okay? And it says multi-conductor cables are installed in accordance with 392.22A. We saw that. And single conductors shall be installed in accordance with 392.22B and whatnot, okay? So that type of thing. Those are pretty straightforward. Very rarely do we mix the two. I mean, you could mix the two, but usually all we're saying is treat each one of them separately when you're doing the ampacity values. Treat them separately, okay? And then we're just making sure that the combined fill value for those conductors that are in there and those cables that are in there, that they're not going to exceed 100% of the cable fill percentages of that cable tray. Makes sense? I don't have any pictures. Oh, you mean the different types of trays? Yeah, I think I have this right here. So this is a ladder rung style. This is a solid bottom. Okay, got sidewalls on it. This is a trough type. This has the ventilated trough with the open ventilation on the bottom. This is what a solid bottom, as it sounds. Basically, it's just a tray. That's all. Here's a channel. Channels typically are smaller. They're limited in width. They come in solid bottom or perforated. And then, of course, you have wire mesh style, right? And then, of course, you have a single rail. Also, do not discount the manufacturers. Always reach out. And also NEMA, by the way. NEMA has a great document out. You just search for it. Search for NEMA cable tray. It may be older by now. I don't know if they put out a new one, but it's still applicable. It still works. NEMA's cable tray installation guide. Go Google search that. And that has a step-by-step guide that is really good too. It's really good. I mean, the reason it hasn't been updated probably is because it probably doesn't need to update it, except for if some of the code references have changed, then that might throw off some people because of the code changes, that type of thing. Okay? All right. That's the basic. I don't want to get too deeper than that. That's basically your ampacity values. Let's do some giveaways real quick before I have to let you guys go. Let's go over to the contest. And let's see here. I'm going to spin the wheel. Oh, by the way, look for that video coming out a little later today called the winners video. And if you see your name, there will be instructions at the end of the video for you what to do if you won during the first quarter. This is for the second quarter drawing right now. Okay, so let's spin the wheel and get some giveaways. Red Dog. NFC promo. And I don't know if you've already won one of those, so let me look real quick. Bear with me while I check. If you won one, you don't need two. You already won one. Or you're in the drawing for one, Red Dog. So let's spin you again. You're already in the drawing for one of those. I just verified you here. For a 2023 enhanced. And I don't know if you won. Yeah, I'll look on that. But anyway, you're in the drawing for that. So congratulations. Let's spin again. Remember, hashtag win to get in on the spin. You like the Willy Wonka wheel? People saying it's hypnotized. Oh, God. All right, we got to do that again. No way I'm giving everybody one of those damn things. Brandon, I'm not sure what you're saying. A multi-conductor cable is where you have two or more conductors on a cable together. Single conductor cable is based on its construction. It's called a cable because it has an inner core, copper, aluminum, whatnot. It has insulation, and it typically has another sheathing on top of it. There are, for example, PVC. PVC typically are insulated conductors, but they do make one where you have the core, right? And then you have insulation, and it has an extruded sheathing over top of that. Okay. You also could have a single conductor cable, or you could have a, for example, MI cable can be considered a single conductor type of thing, but because it has a sheathing on it, you could call it a single conductor cable. There are MC cables out there, especially ones, for example, 2-hour rated type of MC cables that have a single conductor inside of an armor. Those are still called single conductor cables because of the construction. But typically, when you see a multi-conductor cable referenced in the NEC, it's going to have two or more conductors a part of what's called a cable assembly. So they're plexed together or twisted together as part of a cable assembly. I will remind you that in the front of your NEC, Article 100, you have definitions for things like cable assembly, things like that. So I encourage you to go look at your Article 100 definitions. All right, so Tara Williams, you get an NFC. You're going to be in the drawing for those NFC cards. Again, you can reprogram them to promote your business. You can program them to whatever you want it to be. It's simple. It's free. It's a free app that you can download to program them if you want. But again, it's basically going to be a coffee hour card with a NFC chip in it. And I have very limited on these, but it'll be engraved. And when you get it, it'll have our information on it about coffee hour and whatnot, so you can share it with friends. But you can reprogram it. Don't worry. You're in the drawing for the Trade Hog. All right, Miles. And also, I should tell everybody the Trade Hog is getting ready to get an update because it's getting smarter. Jeff has been working on it, and it's actually has a new model that we're going to be testing out. It's going to be in what's called an intuitive model, which means it's going to be a more progressive learner, and so it remembers things so even better. So that is cool. TradeHog is always getting better. Also, I should remind you, Brandon, use tradehog.net. Tradehog.net. Ask it questions like, what's the difference? What is a multi-conductor cable? Is it the same as a single conductor cable? All those type of questions are great questions to ask TradeHog. And it will give you all those questions that you have. Try the hog. It's free, but you get to try it 3 times per hour. And so give it a shot. Or you get to ask 3 successive questions if you want, that type of thing. So give it a shot. It'll explain things to you. All right, let's do another one here. We're going to have to be more specific. How does PVC demand be in the current housing, electrician, construction? Not sure what you mean. Are you asking a code question, or are you a manufacturer? I'm also work for Prismium Encore Wire, so obviously I would not promote a manufacturer of other products, right? PVC is the predominant used insulation type in most building wiring. Although there is a thermoset like a cross-linked polyethylene that is probably a more resilient, better dielectric constant properties, has less leakage current. It's better to resist chemicals. It's a cross-linked polymer that is more resilient to abrasion. All of that is going to be better than a PVC. Is a PVC still okay for use? Yeah, sure. THHN, THWN-2, PVC installations, great. That type of thing. PVC is used, for example, in PVC raceways, perfectly fine. No problem with those type of things. So I'm not sure of the question, okay? Let's see, Born to Plumb, Jim, I believe that's your name, Jim. Born to Plumb, you have got an NFC. You're in the drawing for an NFC card. Congratulations. Let's spin again. Oh, Tara, I didn't spin you? I thought you did. I thought I gave you the NFC card. Okay, we'll spin you. I'll spin you. If you don't want the NFC, I'll spin you. All right, well, that was a delay in there, right? Says Soiati, or is that an L? I don't know. That's an L. Looks like an L. All right, so that's your VD card. All right, so we'll spin you again, Tara. Let's go. I'll get rid of that NFC card. I don't have the greatest memory, Jim, but sometimes I do remember. All right, Tara, you're in the drawing for Trade Hog, okay, which we just used a minute ago. That type of thing. All right, let's spin again. I'm in the giveaway mood today. I took you too long. I kept you over an hour now. You're most welcome, Tara. Trade Hog is really going to benefit people in the field. You are in for the NFC card. You already wait a minute. You already have that. Okay, so let's spin you again. Spin you again, man. It's trying to give you the same stuff today, Red Dog, over and over again. I don't know why. See what we get. Oh, let's see. Red Dog, are you registered for? Okay, so this is for the drawing, so you're okay. So Red Dog, we'll put you in for a Trade Hog drawing. Okay. All right, folks, one more drawing and we're going to let you go. Let's go. Remember, hashtag win, get you in. I appreciate you joining today. Hopefully I didn't go over too quickly the ampacity. Just remember, for most all cases, when it comes to trays, when it comes to cables, use 310.16 and you'll be okay. When it comes to single-insulated conductors or single-conductor cables used in a cable tray, you're allowed to use 310.17, but you have some reductions that you have to follow, percentages, that type of thing. And you get to ignore 310.15c1. If you choose not to use the allowances in there, then you're going to, and you're using the ampacities in 310.16, then you have to follow the rules in 310.16 for that as well. All right. Okay, so Manny. And if I confused anybody, that's okay. Mike Holt does a good job. You can go watch him over on his channel. Ryan Jackson does a great job too. You can go watch him on his channel. Anybody that is unhappy with my coffee hour, you don't have to watch. Okay, just saying. That's all I'm saying. All right. So Manny, did we spin, Manny? Did you get the 12 months Trade Hog? I don't think did. I spin, Manny? I can't remember. Let's do it again. Let me know, Manny, if you want the 12 months. If you want to get in on the 12 months Trade Hog drawing, let me know. Otherwise, I'll spin you again. I can't remember. Am I not focusing on here? I'm whining too much. Or you already have the tubes, so we're going to spin you again. Unless you want the register to get in on the drawing for the Trade Hog. You might want that because people, that's a subscription, whole year. All right, actually, you're in the drawing for a minimalist wallet. We'll just do that. A minimalist wallet drawing for Manny. All right. All right, folks. That is going to be it for today. I appreciate all of you. Thanks for joining me. Hope you got something out of ampacities today. Again, trying to do this in a short amount of time. Typically, when I teach cable trays at university level, it usually is a full week that we go over it. So trying to do that in a couple of days and trying to give you the really high level of it can be difficult, that type of thing. If you have any questions, I encourage you to use paulabernathy.com. Just go to paulabernathy.com, put in your question, and be as descriptive as you can. And that's easier for me to answer it that way. Also, if you're a Fast Track student or you're in our programs, don't forget that you have Fast Tracks Interact. Let's get to using that to ask questions, post questions, things like that. And again, don't be afraid to try out TradeHog over at tradehog.net. Put your question in there, see what it says. If you don't like your answer and you think it's not right, copy and paste it and go into Fast Tracks Interact and paste it, or send it to paulabernathy.com. It's simple. All you do is go to paulabernathy.com, boom, done. If you have the mobile app, you can get to all that from your phone. You don't need to even go to the internet. You just do it from your phone. All right? Till next time, folks, stay safe. God bless. And I'll catch you on Monday for another coffee hour. And again, remember, we're going to play the video for the winners of the first quarter today. And make sure you watch the whole thing so you can get instructions for what you need to do if you're on that list. Take care. God bless.